Today we'll be looking at functions defined by equations, but really what this is mostly about is getting used to the whole idea of function notation. Like a lot of higher math, these things can look complicated but are actually quite simple. So if, for example, I think most of you, when you think about function, you think about our old function machine game, which we replicated today in class, and of course you were smart and you gave me 0 first, which yields -3. And if you think about it, just as an aside, that makes this the y-intercept. That's a good starting point. Anyway, when we put in 2, 1 comes out. When we put in 7, 11 comes out. Before I go any further, I do want to, well actually, when we put in x, most of you were pretty quick to realize that the rule for this function is 2x minus 3. In other words, to find any y, you multiply its x by 2 and subtract 3. I do want to take a minute to stop and review some vocab that we learned yesterday because it comes up all the time. Domain are all the x's, and range are all the y's. So if we were to stop here and say, right so far, the D, or domain, would equal 0, 2, and 7, because those are all the D's, or the X's, I mean. And the range equals -3, 1, and 11, because those are all the y's. And we also know that this is going to be able to be graphed. 0, -3 is this point, 2, 1 is this point, 7, 11 is this point. Ooh, 2 lucky numbers. Okay, so the point I want to make here is that we all know that the rule for our function is 2x minus 3. So previously we would have said every y is equal to twice its x minus 3. The only thing that's different now is we're going to say, this, it's going to look like this, and all it means is the rule for this function is 2x minus 3. Or if we use the right words, we would say the function f that pairs x with 2x minus 3. Or in class we'll just say f at x equals 2x minus 3. We could also use arrow notation. Again, it's complicated just because it looks complicated. Mathematically, it is not complicated. It just means the rule for this function is 2 times any x minus 3. Okay, the thing that does look a little bit even further different is this idea. So my rule for every function is 2x minus 3. So if I say, what is f at 3? That just means if I were to plug 3 into this function machine, what would come out? So if I put a 3 here, because it comes next, what would come out? I think if you look at it in this context here, it's pretty familiar. It just means 3 times 2 is 6 minus 3 is 3. So the function that pairs x, f at 3, is equal to 3 because 2 times 3 minus 3 is equal to 3. This is f at x, and we just plug it in. It's a fancy way of saying plug it in. So the two different in homework, and actually one of them also reviews some common issues with exponents, because not all of these are linear equations. Sometimes the equations that are defined by, the function defines, are actually quadratic equations. And so the problem might say, list the range of, and remember range is y, or what comes out when, okay, list the range of g that pairs x with 4 plus 3x minus x squared. So all of this fancy stuff just means the rule for our function machine is 4 plus 3x minus x squared. And they're saying if the domain D is equal to -1, 0, 1, and 2. Again, it looks like really fancy words, but if this, you don't have to do the work like this, but all it's saying is I have a function machine that with this rule, 4 plus 3x minus x squared, and the numbers I'm putting in are -1, 0, 1, and 2. What are the numbers that come out? I probably shouldn't take up that much room. Okay, what are the numbers that come out? And we will be figuring that out by plugging each of those numbers into the function. So if I want to plug -1 in, I say 4 plus 3 times -1 minus -1 squared. And this is important. We cannot slash and dash here because you have to always do exponent first. A negative number raised to an even power is positive. 4 plus 3 times -1 is -3. And this subtraction sign goes here. So that's actually the hardest part about this, is the evaluating. 4 minus 3 is 1, and 1 minus 1 is 0. So when I plug in -1, 0 comes out. As I said before, you don't have to show this function machine. I'm just trying to connect what looks odd to something that you already know. The next one is 4 plus 3 times 0 minus 0 squared. Well, that's just obviously 4, because 3 times 0 is 0, and 0 squared is 0. So when I plug in 0, 4 comes out. When I plug in 1, that's 4 plus 3 minus 1, or 6. And when I plug in 2, I have 4 plus 3 times 2 minus 2 squared. 4 plus 6 is 10, minus 4 is also 6. When I list the range, I only have to include, I don't have to list a number twice. So the range is 0, 4, and 6. By the way, these numbers of the range are called the values of the function. Mostly, though, I don't want you to get too tripped up on the actual, on the vocab too much. I want you to understand the math behind it. The other way that these problems are sometimes, if they say that given f at x is equal to x squared minus 2x, and then they say with the set of real numbers as the domain. That means the domain is all real numbers. That means we can plug anything in. So we're not limited to a particular set of, individual numbers. Now, when you get a problem like this, they'll say, find f at 4. And then the next one might be f at -3. So we're not looking for the entire range. We're looking for these specific values. And again, all this means is plug 4 into our function rule. So 4 squared minus 2 times 4. 16 minus 8 is 8. -3 squared minus 2 times -3. -3 squared is positive 9, and these two equal positive 6, so 9 plus 6 is 15. F at 2 would be 2 squared minus 2 times 2, or 4 minus 4 equals 0. So now we don't have to say the range equals this particular thing. It just means these are the numbers that come out in these specific situations. The only other thing that comes up in this homework tonight, problems that says for each function find f at 0 and then solve f at x equals 0. So let's say I've got the function that pairs x with 4x plus 7. Well, clearly f at 0 is just what we get when we plug in 0 for x, and that's 0 plus 7, or 7. To find the value of x that will make f at x 0, we simply take 4x plus 7 and say, well, what number will make that equal to 0? This is just like finding the solutions to a quadratic equation. In fact, it is directly related to that. So this is the answer to this one, and this is the answer to this one. So more on functions is coming up tomorrow.